Hello everyone. Hello everyone. I hope you all are well. So in this video I will try to explain the Playfair algorithm in cryptography and network security. So here we have five part of this code because we cannot use any built-in functions. I have also said that in my first video. So let's start this to explain this code. At first we need to use without any built-in functions in this algorithm Playfair algorithm. So here we have easily declared our uppercase and lowercase letters. Then we need to put a custom string length where we need to define the length of the text, and the count will start from 0, and for character in this text count will be equal to 1. It will return the count. Then we need to check the uppercase value. We need to define the uppercase character with the same condition where I is equal to 0 and while I is less than 26, it will return the uppercase letter, and I will be increased plus 1, and it will return false if the condition is not correct. Then we need to check the lowercase letter also, where we need to define the lowercase character. We need to put that in the same condition because we know that the number of alphabets are 26. So then we need to check the alphabets, where we need to define is alpha, the variable name, and if it is uppercase it will return true. If it is lowercase character it will also return true, otherwise it will return false if the conditions are not met. Then we need to convert to uppercase these letters, so we need to use the define upper, the variable name. Here we can see the result, and for character in text we also need put a condition where I is equal to 0 if found false, and while I is less than 26, if the character is lower it will result to upper and it will show found true, and it will be declare a break. Then if I plus or equal to 1, if found equal false, the result will show the character and it will return the result. Then we need to replace the character, so we can define replace character where we need to put text old character and the new character, then it will show the result. And for character in text, if the character is old then it will result to new, else result will be the same, remain the same character, and it will return the result. Then if the character exists, we need to put that in a condition where define contains text and character. For x in text, if x equal character, it will return true, otherwise it will return the false value. And to keep alphabets only, where define equal to keep alpha is a variable name, in this regard we have used, it will show the result. For character in text, if the result is positive and equal to the character, it will return the proper result. Now we need to create a empty matrix because it is a user defined functions we have used. So we need to keep the matrix. We can keep the matrix size here, and we need to also use R for the equation of Playfair algorithm, and we have put a condition here, R is less than 5, the matrix will be append, and the value of R will be increased plus 1 and it will return the matrix. So now we have the part 2 of this code where key matrix generation has been described. So we need to fill a 5 by 5 key matrix because we have 26 letters, and the key matrix always contains I and J alphabet in the same matrix, and other alphabets will take one matrix for each. So here we have the key, we need to replace the character key, and we have the key keep alpha where the name of the variable we have declared. We need a sequence here and add characters from key. So if the sequence is false, sequence will be increase and it will show the character. Then we need to add remaining alphabet letters where J omitted, because we knew that I and J alphabet will remain in the same matrix. So here we have the all alphabet from A to Z, and here is the character in alphabet. If it contains sequence false, it will show the character. So again we need to create a 5 by 5 matrix where index will be 0 and row will be 0, because it is a user defined algorithm. We have done this code as a user defined, so we can put here the number of index and row. So while row is less than 5, because it is a 5 by 5 matrix, and column equal to 0, so while column is less than 5, it will show the matrix row and sequence index. So here we need to indexing the whole matrix, where index will be increased by 1 and column row also increased 1 by 1, so it will return the proper matrix. Now we need to find the position of the character. So here we can see that we need to find position of the matrix or character. If the character equal J and I, row is 0 and row is less than 5, column is also 0. While column is less than 5, matrix row column equal number of character. So it will return the number of row and column and increase the number of row and column one by one. If there is not, it will return -1 for each case. Now we have the display matrix where we need to print the matrix properly. We can use the row, line, column, and put that function in the same condition previously used to get the proper output. So here we can see that if column is not equal to 4, the number of line will be increased and column will be increased, and it will print the line row. Now we have the part 3 of this code where we need to prepare plain text. So at first we need to define a plain text where text will be uppercase letter and it will replace by character text. J and I will be in the same matrix, and here the variable we have already declared name keep alpha text, so it will prepare the output where I equal to 0 and size will be length of the text. Here we have also have a condition while I is less than the size of the plain text, it will take the text, then it will increase it 1, and then if the value of I is less than size, it will add the second text, and in first it will equal second text. It will prepare the first text and the prepare like a demo text x. If I plus equal to 1, else it will prepare the first and then it will prepare the second, then I will increased by 2. We have again the else condition where we need to prepare the first text and prepare the last alphabet, which will be end with x. It will return the prepared text. Now we need to discuss the part 4 of this code where encryption and decryption can be done. Here is the define encryption code where is text and the matrix. So we need to prepare a text here. We need to change the every part of this code where the functions are being declared. So here the size of my text, and we need to put it in a condition while I is less than size, a will be the text and b will be increased text. Here row and column will find the position of our matrix, and row 2 and column 2 find the position also. So if the row 1 and row 2 value are step in the same row of a matrix, it will get the cipher value where we put a condition matrix row 1 and cipher text add with 1 will be mod with 5 because it is a 5 by 5 matrix. If there is the column is same, so we need to find out c1 equal c2 and put it in the condition, same condition for this. Otherwise else condition we need to put the cipher only matrix row 1 and column 2 and row 2 column 1 for getting the inverse matrix. So here I will be increased by 2 and it will return the cipher text. Now we need to define the decrypt part of this matrix. So here the text will be my upper text, and text will be replace character text J and I. And text equal to keep alpha text. Here we need to declare the size of the index. Here we can indexing the size in my length variable. We need to put it in a condition while I is less than size, a will be the text and b will be the increased number of text. So here we need to find the position of matrix. If in the same row r1 equal r2, we need to put it in the plain text condition where matrix r1 will be cipher text c1 minus 1 and it will be mod with 5. In the same column for in the decryption part, we need to find out the plain text with the same conditions, and here will be a else condition where plain text equal to matrix and plain text return from this code. Now we have the main program part where we need to print a Playfair cipher algorithm output where key equal to, we need to enter the number of key and we need to generate a key matrix. It will be 2 by 2 matrix. I have informed that because you can answer it into the code properly and give implementation. So it will print the key matrix here and it will print the matrix also. So we have a choice variable declared where we need to enter the encryption or decryption number. Here is the choice, uppercase letter choice. If the choice equal E, for example, plain text input will be take the enter of the plain text, and for decryption cipher text also encrypt the plain text and matrix. So here we have the print cipher text part. If we have also choice another choice, for example D, here we can put cipher text input as a and get the decryption part of plain text where it will show the cipher text in the matrix. So here we can print the plain text part, and at last we need to put a condition else condition where it will print invalid choice if there is no plain text or cipher text has been used properly. So that's all from Playfair algorithm today. Thank you everyone.